Welcome to the Scale Your Business Better with Tech podcast. I am your host, Jay Farr at Tech Fusion Systems. Our guest is Kylen Hunt from Grow Guru. Kylen, welcome to the podcast.
Thank you. Appreciate it. Looking forward to it.
Can you kick us off? Tell us a little bit about Grow Guru and what you guys do.
Yeah, so Grow Guru started back in 2014, and it really started as a technology company that was designed to help farmers manage their water better in the agriculture space. The individual who started this was very well known in the communication space, and he built a platform using LoRa technology. And LoRa technology has been a struggle, to say the least, in a lot of ways in just the last couple of years. We've actually looked at our entire product lineup, everything that we were doing as a company. And just a couple of years ago, we really refocused the company, moving back into working with cellular, primarily Verizon to start, Verizon Cellular Systems. And we're going to still be working on water management. That's a big part of what we do. But our niche is really working with permanently installed soil sensors that are going into the ground permanently so that we can really engage with farmers at a higher level around things like carbon, things like soil structure and management, and really preparing that root zone for a healthy plant. And that's really what we're looking at as we look at the United States and even globally right now. Water is a massive struggle. It's a big challenge for a lot of people. And food security. Food security is a big deal. And people want to know that they're getting good, healthy food and where that food's coming from. And with our technology being in the ground, permanently installed, we're continuously monitoring soil profile where our crops are grown. And that's really what we're doing today. We're helping the farmers do that and be profitable in the meantime.
Yeah, it's really interesting. It's good to hear that we're making some innovation on that. So it sounds like it started out with basically managing water. Now these sensors that you have are measuring not just the I don't know what you call it, dampness or water concentration of the soil, but also other metrics as well. Do the other metrics go into play in determining how much water the crop needs, or is that just more of a crop rotation sort of measurement?
That's a good question. So the actual sensors that we're using, they only measure two things today: moisture, soil water, and then secondly, it also measures temperature. But the real question is, what do you do with that information? What do we do with the data that those sensors are sending to us? And that's really been our niche area, being able to permanently install these. Of course, the growing season in Nebraska and Kansas, South Dakota, that growing season only lasts about 3 months. So we only grow crops about 3 months out of the year. What do we do with the other 9 months? Our sensors are in there, in the soil, monitoring that soil all throughout the off season, so we can see the impact of snowmelt, right? When it snows, we can see that. When the ground freezes, we'd like to see our ground freeze so it heaves a little bit, breaks up that soil, and keeps that soil structure nice and easy for plants to grow through. We're really watching that stuff in the off season so that we can prepare the farmers for a really good planting environment when they go to plant their next crop. That's really our go-to-market strategy, is looking at that all the different parts of the season, not just irrigation season, not just in season when the plant's growing, but all throughout the season. Now, the unique thing about our sensors, though, and what again is setting us apart, it's what do you do with the data? And we're really focusing in on plants, and the way that our technology reads, we can watch the plant root system grow. Since we're permanently installed, we can see how much the spring rains are impacting our soil profiles. We can see what the whole planting environment looks like for the farmer when we go back and treat that soil the way nature intended it. Start with a full profile, have it well structured. When we plant that seed, we can watch that root system go deep into that soil profile. These sensors literally allow us to watch a root develop right off the plant, right into that soil profile. As that root's developing, we can measure and see how healthy that plant is as it's growing. That's a huge element. One of the things that's often forgot about in agriculture is how important oxygen is in that soil profile. That there has to be air in there, especially with some of the newer technology in our seed products today. We have to have good oxygen to water ratios. And that's really one of the things we watch is how healthy is that root as it grows down through the soil profile. And that really differentiates us now as we're looking at our competition. We're looking at other people who use similar technology as us. We're just using it in a totally different fashion that allows us to bring a higher value to the grower and, to be honest, a higher understanding of what that plant is going through deep in that soil profile.
Yeah, that's really cool. I'm guessing that by optimizing all of these environmental factors as you're monitoring, you basically can optimize the output of the crops, right?
Oh, absolutely, absolutely. Yeah, if we can optimize all the environment, because a plant, after you put a seed in the ground, it's at the discretion of nature. It's either going to grow because it gets some rain, it gets sunshine, it gets that impact. But at the end of the day, if we don't get the rain, if we don't get the sunlight, if we don't get the warm temperatures, we're able to manage that. We're able to see how it's impacting that plant below the surface. If we have a good root system, we call it, if you've got big roots, you'll have big fruit. And that's the way it is, right? Big roots equal big fruit, and that makes money. So those are the things we look for.
Yeah, it makes sense. And like, how many sensors do you need in a crop to accurately measure and monitor these conditions?
That's another really good question. Currently, today, when we start with a farmer, when we start in an organization's cropping system, we will normally just put one sensor out to get started. And we'll strategically place that sensor in the field in a very unique place, because remember, we're not taking the sensor out. Sometimes sensors will go in and they're pulled out in the same season. We're going in to install this thing once. And right now, just a little background on our hardware, we're installing below the surface and we're tracking about a 7-year lifespan on our underground elements, which is really good. Competitively, where most of our competition is looking at one season, one growing season, so 3 to 6 months. And we're able to put our technology in the ground and have it run what looks to be about 7 years. Right now, we're going into 5 years with 50% battery on our underground, so we're really excited about that. But with that being said, we will strategically place that sensor in one place in that field so we can start monitoring just that region. However, we do have technology that's coming out in the future, and through the use of AI and machine learning, as we are learning what those soils are doing with our permanent installs, we no longer have a calibration problem. Because we're permanently installed, all calibration issues with our sensors go away, completely disappears. So with that, we're able to long-term look at placing other sensors, maybe some lower cost sensors, into the soil profile in some of our outlying areas. Maybe it's an area where we have heavier soil or lighter soil. And with, again, permanently installed sensors, collecting data, perfectly calibrated, implementing machine learning, we're able to start looking at variable rate applications of water, what we call variable rate irrigation, or VRI. That's an element that the industry has been looking for almost 20 years. The technology has been there on center pivots. The technology has been there on drip automation and things, that drip irrigation automation, but there's never been good data that gives us the ability to create the prescription. Now we're going to be able to come in, bring the good data, write a prescription that's very accurate, and build that prescription from the root zone where the water's actually working. That's what's really exciting about our technology, is not just what we can do with it today, but where we're moving with perfectly calibrated technology. It's a game changer, man. I'm telling you, it is a game changer. Calibration has always been a problem in this industry, and we're eliminating that problem.
Yeah, it makes a lot of sense. Basically, by what you're saying is traditionally not always put the sensor in the exact same place, and that's where the calibration problems come from. Got it.
That's part of it. The other part is though, think about it this way: we've got all these different soil types across the United States, right? Around the world, soils just change. They're different by nature. But at the end of the day, think about a manufacturer. Anybody manufacturing these sensors, they have to ship that sensor out not knowing where it's going. So these sensors are coming out calibrated to an industry average. It's really hard when that sensor's coming out perfectly calibrated, and then all of a sudden we're putting it in an imperfect soil environment. How do we know we're right? How do we know you're accurate? Even if you can post calibrate, but you got to pull the sensor out at the end of the year, even if you post calibrate and get it right once, you may not get it right the second year. Even if you put it back in the same hole, it may not be right. And that's been a huge problem in this industry. I'd say it's been a problem for 20 years. And with a permanent install, though, that never moves, that sensor's in the ground, it never moves, and our sensors are just perfectly calibrated from one year to the next that way. And it's not that we are calibrating to the sensor in the soil, it's that we're calibrating the time. We're consistent year after year. And that consistency is what gives us the ability to maintain and grow with machine learning.
Yeah, that makes perfect sense because I have a background in manufacturing automation. So I understand variable water and irrigation and throttling and drip control and that sort of thing. But yeah, it's very interesting that the whole time the data has been the problem and the bottleneck in that kind of process. And so what kind of determines, I come from the country, but I'm not a very good farmer. Help me out a little bit. Like, I'm guessing basically within a really large, plot of land, you'll have areas that get more sunlight, you'll have areas that get more rainfall, maybe down off of a hill, you get a lot more runoff, a lot more snow melt, things like that. Are those some of the variables that are going to determine throttling different irrigation rates? And what are some of the other ones?
Yeah, again, a really good question. You're exactly right. Topography is a challenge. Soil type is a challenge, underground soil type. Historical management of that soil is all that stuff comes into play. Even the current management of that soil are some farmers just due to where they live and how their soils respond to rain events and things like this. Everybody uses different tillage practices, right? All of this goes into play on how well the crops are going to produce, where we place sensors, things of that nature. But really what we're looking at, if you think about the purpose of having any type of sensor in the ground that's going to measure moisture, it's really the impact of what is the moisture from the environment done to the soil profile. For example, if it gets really hot, let's say it's July, it's really hot, it hasn't rained for a couple of weeks, that plant is drawing a huge amount of water out of the ground. It is trying to dig deep, and it's finding water anywhere it can find it. And the plant will go as long as it can until it literally dies. But if let's say we get a 2-inch rain, and most people think, man, 2-inch rain, that's going to be amazing. It depends on if that 2 inches comes in 20 minutes or if that 2 inches comes in 2 or 3 hours, right? A 2-inch rain in the rain gauge doesn't really matter. It's how much went into the soil profile. So if you're where I'm from in central Nebraska, we've got hills. We could have 150 feet of variation in the same half a pivot span. It's just huge hills up and down. And it's really a challenge with runoff in those scenarios. So that's where the idea behind variable rate irrigation comes in. If we have different sensors in different places around that field, when we do turn the water on, we're turning it on to match what is needed in the soil profile. We put it on to match what the plant's demand for water really is. And in the low ground, if you're in a low valley, for example, that low ground, it doesn't need as much water oftentimes because you don't have the wind hitting it. Just like you mentioned, the wind isn't there. Sunlight might be a little bit different. It gets extra water from runoff. So those low areas, we want to be able to back off the water a little bit, let that soil oxygenate a little bit more, and focus more water up on the top of the hills where the wind is real heavy, we just don't get as much water into that ground. Those are things that we want to be able to do with this technology, is help the farmers get really good at managing the impact of the environment, managing the impact of that weather throughout that growing season. The better a farmer can manage the impact of weather, the better a farmer is managing the impact of weather, the more profit they're going to make, plain and simple.
Yeah, that makes perfect sense. And I'm curious about your devices. What do they look like? How big are they? And are they battery powered? They're not solar powered at all, and they're all under the ground?
Yeah, again, another really good question. Our underground elements are all plastic and they're all sealed very tightly because they're underground. We don't want to have to go pull them out. And that's something that our manufacturing team has done a tremendous job with. They have sealed this thing very tightly, but surprisingly, it's a 3-inch PVC pipe. That's all it is. It's a 3-inch PVC pipe. It's only about 6 to 8 inches long, and all of our technology is inside of that. And then attached to that is a long 4-foot probe. So we're actually measuring 4 foot deep into the soil profile. And there's 6 individual sensors on that long soil sensor, that long probe. So that's our underground elements. And inside of that is just a very simple D-cell batteries that are running on a very low power system. And that's what's given us that 5-year lifespan. Think about it. The guys that built this technology to be able to pull a reading off of that soil sensor every 30 minutes, and it runs on D-cell batteries buried below the ground.
Yeah,
So these
that's
guys have done
amazing.
a tremendous job. It is amazing. I look at what they've done and it just blows my mind. And then above the ground, somehow we have to get that data out of the underground. So we do have an above ground device. It's again just all PVC, no wires on it. There's no cables on it anywhere. And we're able to run that on 2 D batteries, and we're pulling that data from the underground up into our device that's above ground. It's on a post of a 2-inch PVC pipe, and then right at the top of that post, there's a 45-degree angled 3-inch PVC. That's all it is. It's a 45-degree angle that angles down into the ground, and it's receiving data from the underground. Everything built out of PVC, sealed up really tight, so that we just don't have water issues. No solar power, none of that stuff, and it really makes it nice and easy to work with.
That's amazing because I am an electrical engineer as well, although not practicing anymore. But to get that lifespan out of that small amount of power is really impressive. That's some good design that your team did there. And this is transmitting that data over cellular?
Historically, up until this year, we've been sending it over LoRa technology, which if you're familiar with LoRa technology, it's almost like a competitor to cellular, but it's a really low power system, which if we're going to get batteries to last that long, we have to use low power, right? Today, there's a system, and this is outside of my realm of expertise. I know the big words, I guess you could say, but Verizon now has come out with a competitor to LoRa called Cat M1. And that is what we're building our technology on today. We're moving back to cellular, using cellular devices. They're actually just releasing this fall. And we're going to move away from the LoRa technology and move all into cellular-based technology using this system called Cat M1. And that still gives us the ability to use low power frequencies to pull our data from the underground.
Yeah, that's interesting because that was one of my concerns when you started talking about the low amount of battery that you need to last that long. And I was thinking, if you're sending that over cellular, I don't have a schematic in front of me, but I'm not sure. That sounds crazy. So it makes a lot of sense. The amount of power needed is obviously reduced with those technologies. And no, I was not familiar with LoRa, and now you're saying Verizon has their
Yeah.
version of it now. So that's pretty neat.
Yeah. So a lot of people in the ag industry have tried to use LoRa technology or LoRaWAN technology, and it's been a struggle. because you can't send the massive amounts of data through it like you can with Verizon. It requires a base station of some kind that still connects to Verizon eventually, or some kind of a cellular system. Eventually, you got to get the data to the platform. So it's really been a struggle working with LoRa technology, because it's like another third party right in the middle of this data stream that you have to maintenance and maintain. And it's been a struggle to keep all that working as we've been beta testing this. But Verizon's been awesome coming out with Cat M1, and that's going to be a big relief for us to just be able to focus on selling our systems and doing like we're supposed to do in this industry.
Yeah.
Fixing telemetry.
Yeah, I definitely understand. But it sucks to be in that development process where everything's in line, but you have that one bottleneck piece that you can't control. And that happens sometimes. So it's great to hear that better alternative is coming out. When do you think you guys will have that fully designed and tested and ready to roll out?
Yeah, so it's in testing right now. It's in its final testing right now. And our first 50 units are being shipped out at the end of this week. So we're going to be getting our hands on the first 50 units here, and then we've got several hundred that'll be out before the end of the year. So that's where we're at. We've been testing all the underground components. We know those work. The only thing that we're testing now is this cellular system. And it's, like I said, it's in final testing right now. And in fact, just before I jumped on this call, I got off a call with our CEO and our manufacturers, and it is on its way out this weekend.
Cool. That's fantastic. I'm rooting for you guys. Hopefully everything runs smoothly, exactly as planned.
But you know how it goes. You get it. It always works. Come
Yeah,
on.
every time.
Every time it always works. Yeah.
Yeah.
I've always joked about why anybody would want to be in this industry. We put electronics out in the field where we put water on, right?
Yeah.
And then we expect no problems.
Yeah, exactly. Yeah, it's I don't think a lot of people realize how harsh it is to put something underground for that length of time. Go and put something underground and dig it up in 5 years. I don't think you'll find it most of the time. Yeah.
That's right. Yeah, exactly. It's a challenge when you put something under the ground and then you want it to run for 5 years. It's holy cow, because we're guaranteeing these things to run 5 years. That's our guarantee. Otherwise, can't really call it a quote unquote permanent. Even though we're at 5 to 7 years right now, we're still not permanent per se. But it's in the big scheme of things, we're getting a permanent data flow. Because this is another unique element to what we're building with our software. As we start tracking that underground battery life, as we start to see that battery decline, we're going to go put a second sensor in right next to it. And then those two sensors will work together for one complete season. And we'll connect that data flow together. On the farmer side, when they look at the software, they'll never see a glitch. They'll never see a data hiccup. So that's going to be part of what we do, is we just sew or mend that data together. So even though one sensor's dying, a new one's starting, and the growers just never see the miss.
Right. And there shouldn't be any data irregularities either.
That's correct. That's correct.
It's fantastic. So what types of farmers and growers are the types of clients you can help the most? Who should be reaching out to you guys and taking a look at your product to see if that'll help them?
The primary market that we built this product for is the row crop, a farmer that's primarily growing corn, cotton, soybeans, a lot of what's grown in the Midwest. As we're launching this product out, we're heavily focused on Nebraska, Kansas, and Texas is our primary focus region, because that's where we're growing all the row crops, or a big percentage of them. But we've never had the opportunity in this market to have a permanently installed sensor, something that can go year after year. So that's why we really targeted this and said, okay, what can we do in this market? In fact, a little background on me, our chief science officer, chief agronomist, I guess is what we call him, chief agronomist, David Sloan, he actually brought the technology to the United States, him and a small group of people many many years ago. He's been in the sensor industry now about 29 years, and he's actually trained, if you will, the United States. So he built a company called AquaSpy, and I was helping our team build a company called Crop Metrics. So for many years, David and I were competitors with each other. And we put in the same types of systems. We had the same business models, go-to-market strategy. Everything is very uniquely the same. And we were just fighting for the customer. Today, even though David and I were strong competitors, we were also really good friends, and which has been really cool over the years. Today, now he's working in the company with us, and we're working on this together. While we were competing for so many years, now we're completing. I call it we moved from competing to completing. And he's got strengths that I don't have, and I've got strengths he doesn't have. And so we're working together on this to bring our expertise in to help the farmers in this row crop market that are normally highly underserved. And they're getting pressure from consumers. They're getting pressure from governments and things of this nature for water quantity, water quality issues. And our sensor is able to help improve in every scenario. That's really why we're focused in on this row crop market that's so underserved with this type of technology.
Yeah, it's really great to see that innovation, and it's just nice to hear it coming from a lot of farmers in my family, and it can be a tough business. So I'm glad to see something like this rolling out that can make the whole process better for everyone involved. And I love your competing to completing. That's fantastic. So it's good that you guys teamed up. That's sounds like a win. So
Yeah. Yeah, it's exciting. And David and I, like I said, been friends for a long time. And my wife and I actually run a leadership and business development company on the side. I was actually how I got connected with David. We were doing a leadership training. David attended one of our events, and him and I started talking about business models, go-to-market strategy, the value of long-term data. This is some of the things we talked about at supper one night. And then next thing, here we are a few years later, working together on this very thing that we dreamed about over a steak dinner. It's pretty cool how you see things come together.
yeah, that's awesome. I wish you guys all the success. You have a fantastic product. It's obviously a need in the market. I think you guys are going to do really well.
Awesome. Appreciate that. We're looking forward to it. It's a unique delivery, probably higher price than what a lot of our competition sees out there, but that's okay. We're going to bring a higher value, and we want to bring that value to the market in such a way that it's not about the product, it's about the purpose behind that product, which is to drive up yields, drive up profits, and conserve our resources and help us just produce a healthier, better crop for all of our consumers.
It's fantastic. I'm sold. If I was a farmer, you'd be my first phone call. So
Tell all the farmers, man, tell them all to call me.
I will. I will. Let's see. Yeah, I think we pretty much covered everything that I had questions for you about. Any last thoughts or anything you'd like to leave the audience with?
No, not really. I would just challenge the audience to think about agriculture, not just think about, but learn and really understand where your food comes from. Become a consumer that wants to be educated. David Sloan, he's the one I shared with you earlier. He has a desire to educate an industry. And as he's looking at his legacy, is going to be built around education. The thing that I would challenge our audience with here today is if there's something you don't understand about agriculture, if there's something that you want to know more about as it pertains to your food and the food that you put on your plate, reach out to us, because we're an industry that wants to educate consumers. We want consumers to come out to the farm and see what this is like. We want consumers to come into the small town environments where we're growing a lot of these crops and talk to us about how we're conserving biology and what we're doing to conserve our water at the same time we grow good, healthy food. Those are the things that we want to be able to collaborate with consumers on. So that's my challenge to a consumer is if you have questions or if you're concerned about something, get a hold of us. Come to the farm, Let's spend a couple days out there together and let's learn and grow together. Because at the end of the day, Jason, there's one thing that I've learned. There are so many more things in this world that unite us than there are things that divide us. And it seems like we've been in an environment in recent years where there just seems like there's so much division. But when you can come together and everyone wants to eat, everybody wants to have healthy, clean water, everybody wants to do these same just basic things every day, let's learn together where that comes from. And let's learn together on how we can make it stronger, better, and healthier for all generations to come. The better we get at collaboration and communication together, the better we're going to build this country, build it strong, build it the way we know we all want it to be. And so that's my challenge to the consumers. Come out and talk to us. We're looking forward to it.
That's a beautiful and heartfelt message. Kylen Hunt, Grow Guru. Thank you so much for being on the podcast.